how they play. Who knows what kind of a color we use to add meaning? We want to add meaning to action words, and what color does that?
Light blue,
Light-
adverb.
Adverbs, correct. And their position is very logical. They're located just beneath the words they describe. Clever Krishna plays, let's say, happily. Often the words that are adverbs end in ly. Sweetly, happily, joyfully, frequently. So we write the word happily in light blue. Happily. And we underline it. We have the marker. We're going to extend the slanted line on our diagram so the whole word fits. I'm going to extend this line. Now we're going to see one, just you see how this builds. And actually, knowing this helps children build sentences. It's called expanding their ideas, so that they don't just express themselves at a very elementary level. That this is used to help children develop, expand an idea by using precise language, remember, Balinese literature, by using modifiers, by using prepositional phrases. Let's try another thing. Let's see how it works in our sentence. Clever Krishna plays happily in the forest. Oh, now we've added some more information, right? Well, did you hear the word forest? What do you think that might be? Forest. Forest, does it show action?
Sorry, a noun.
The noun, right? It names something, right? So what color will we write forest?
Red.
Right. And okay, we will put that on the bottom of this little aperture here. This looks like an elbow, an arm, like this. We will write the word forest in red because right away it tells us that it's naming something. Forest is a word that names, right, a group of trees, a large area covered by trees. Now we're going to try a new color. We heard the word in, right? Clever Krishna plays happily in. Purple preposition. It shows the position, the placement, right? Between forest and where he plays. Where does he play? In, right? So with purple, on the slanted line, we will write the preposition in. This is called a prepositional phrase. In is the preposition, and forest is its object. But there was one more word. The. Krishna, clever Krishna, plays happily in the forest. So the is an article adjective. It's one of three. A and the. In English, we have three article adjectives, a, and the. So we have heard this as in the forest. Where do you think, now just use your head, where do you think the word the will be placed? What's the word after the word the?
Forest. So
Very good.
I guess before forest. So
It would be placed beneath it because it's an adjective article. It defines as definitive the forest, right? We could say plays in a forest, but in this case it's a definitive article, plays in the forest. What color do we give to adjectives? Do you remember? These are words that modify or pink, correct. The articles are also classified as a specific category of adjectives. Only three of them, not too much to remember. So the word the applies to forest. Which forest? The forest, right, the forest. Okay?
What was the three article adjectives? Sorry.
Article adjectives. There are three, a and the. first two are called indefinite. The word the is called definite. I'll give an example. If I say, please hand me a pencil. It might be anyone, right? If I say, please hand me a pencil, it could be any pencil. It didn't specify which one. And if the next word starts with a vowel, please give me an apple. I have to use an because apple and a would blend, and we would not be able to distinguish where one part of one word stopped and another part. So we have to put the n to show the break. So please bring me an apple for the offering. An and a are indefinite. It doesn't say which one. But if I say, please give me the pencil, I'm now indicating that there's a particular one I want. Do you see the difference? If I say, please give me the pencil. If I say to you a pencil, you might just hand me one from your little bag of equipment. But if I say, please hand me the pencil, I'm definite. I'm indicating there's a specific pencil that I want. So this falls into the category of specific category of article and general category of adjective, because these will go before. You'll see this word a, an, and the on every page of every book, without fail. Without fail. So now we have constructed and expanded from the single word Krishna. We have developed a simple sentence. Clever Krishna plays happily in the forest. So let's test you, Yashoda. Would you tell us a little bit now about grammar? You've had a very short lesson,
Alright.
and with the help of color and with the help of architecture, called diagramming, tell us what we can understand from this diagram and hold it up for the people and see what we know now. But if we were to analyze this, let's just say the architect presented this, and now you're the designer, and you're going to be able to figure out what he wants you to do, okay?
Okay, so here we can see quite clearly that we have a story which is in two sections. Firstly, there is the subject, and then on this side we have everything to do with the subject.
Predicate, it's called predicate, right?
Predicate. So Krishna is the subject, and Krishna is a noun, so nouns are written in red. We can clearly refer to this, and we know instantly without even needing to think that red is for nouns, so Krishna must be a noun. And if we want to know a little bit more about Krishna, we can see here he is clever, which is this is pink, isn't it?
Pink, right.
So this is an adjective, so it's describing the noun, subject, Krishna. We have another adjective down here, you can see. So then we move into the predicate, where we find out everything about the subject. So first thing is that we discover the verb plays, which is in blue, dark blue.
It shows action, right?
This is the
just
action
word, action
Those are
word.
the action words. And then of the action word, we see how Krishna is playing. He's playing happily, which is the adverb. So describing the verb. Moving along, Krishna plays happily in, which is, this is a preposition.
Preposition,
Yeah.
preposition shows it, right?
Yeah. So that's
Shows relationship.
Purple, I think. Yeah. And that shows relationship. And then moving along to forest, we already have one noun here, so forest is our second noun. Red, primary color, that's one of the main four grammar functions. So Krishna's playing in the forest. And the, which is again the same as playing, adjective. And this is specifically an article adjective of which there are three in the English language, which I just heard. The is, out of the three, the only definite article adjective.
Very good, very good.
And
And the prepositional phrase is placed under the verb because it's showing where he plays. It's not shown under the noun. There are prepositional phrases that could be that could be attributed to the noun. But in this case, this prepositional phrase tells where. So it tells its function is that it would be placed below the verb. Placement indicates the relationship. So we see
That's
here.
very clear.
Right, and very clear. So after your short lesson, do you feel you have a little better
Yes, what did
visual appreciation of grammar?
Even from here, if I don't see the words, I can see the colours. So then I would be able to figure out where the nouns are. Where the verbs are.
Exactly. And then if the child can write a sentence just in pencil, he can write a sentence. And then we often gave children, as I said, we saw those simple books, those picture dictionary books with simple sentences. Right away they were reading the words, and like Sally has an apple and a pear. Sally would be in red, has would be in blue, Anne would be pink, apple would be noun, Anne would be light green, A would be pink, and pear would be what color?
Red.
Good.
Yeah.
So right away, the whole page, they're indicating grammar.
Revolutionary grammar.
Revolutionary grammar, we call it rainbow, Krishna's rainbow. So by expanding on that, and there are wonderful books to help you diagram sentences that are compound, complex, with all kinds of gerunds, infinitive phrases, participles that can become a very involved thing, and even a child of ordinary ability can function on an extremely high level of understanding. Hare Krishna. Times 11 equals, we take the other number, we put the 1 here and the 6 here, and we put the sum of the two numbers in the middle.
176. That is amazing.
Okay? Now that works up to a point, just as the other one worked up to a point, right? In other words, 3 times 11 was 33. But after a certain point, we had to go to a new strategy, right? So that's going to 11. So the very first day that we teach tables, we eliminate so many by knowing all of the zeros, we know all the ones, we know how to do all the tens, and we know how to do all the 11s. And then when those come up later, 0, 1, 10, and 11, when I'm knowing, let's say the next thing I want to teach is the 2s, which is what we do teach next. So we've already learned the 2s with 0, the 2s with 1, the 2s with 10, and the 2s with 11. Each time we take on a new number that we want to learn, we've already chopped we keep chopping it down. It becomes fewer and fewer multiplication facts to learn. Do you follow that? Right? So if I learn my 2s, I've already done, I know 4 of them.
Yeah.
And these were practically no work, were they? So, no work and then a little bit more, but not much more. So the 2s, it's the same thing that we did before with the strategy, it's the doubles, right? Every number's double. So we start with a 0, and then we write to 1, 2, 3, 5, 6, 7. We're 6 on this column, and then 8, 9, 10, 11, and 12. Okay? So everything now is going to be multiplied by what? 2, right?
Yes, ma'am.
So we have the children write this out, or on the board I would write it out. So everything can be visualized. We did a lot of writing out of the facts, not only by mind, but writing out so that they're very fast at doing their operations, on a test or paper. And we would put the little equal signs quickly through the whole thing. So now we're going to learn our 2s. Now normally the way 2s or any of the multiplication facts are taught is just by sort of almost a musical repetition. 2 2s or 4, 2 3s or 6. You've heard children chanting like that, right? But our approach is more analytical, right? And the problem with the other method is that it's based on just trying to remember the facts rather than understand that, do I know something already, and what strategy will I apply for the rest of the rest of the procedure to make this fast. So what we did was we circled the ones that we already knew. The 0, the strategy, the 1, right? The 10, and the 12, and the 11, sorry. So that leaves us 1, 2, 3, 4, 5, 6, 7, 8, 9 left. Right away, we figure out how big is my task analysis. Is there some way I could reduce the job? You know, is there something I already know that will help me see I know more than I think I do? Or that will help me see it's not as hard as I might have thought it would be, okay? Task analysis, very important. Now we understand that the 2's are doubles because we double something. Times 2 means I double a number. And we've already done that before, right? When we did our, so remember 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And now we have to go a little bit higher, 22, 24. Let's put the answers for the ones we know. We know 0, right? Times any number will give 0. So that one we know, we got that one. And we know anything times 1 will be the number itself. We know that one. And we know anything times 10 means I add 0 to that number. We know that one. And we know 11 means I just write the number twice, 22. Good. So I not only by my mind mentally know the answer, visually now I can see 0, 2, and 20 and 22, just off the bat. And because I've learned doubles before, I know that my answers will be doubles. And what we do with each one we taught, we would show the student that number in terms of counting by that number, right? Like if we count by 2's, or count by 3's, or count by 4's. Show them how that appears in a lineal fashion as well. In other words, to get a complete understanding of every aspect of the times tables. Okay? So we know that 2's is very simple, it's doubles. So 2 doubled is 4, and 3 doubled is 6, and 4 doubled is 8, and 5 doubled is
10.
Yes, we've done this before when we added, right? When we did our doubles. And 6 doubled is what?
12.
And 7 doubled is,
14.
and 8 doubled is, and 9 doubled is 18. Okay, we already know 10, and we already know 11, and the only one that we have to learn is 12, right? 2 12s is 2 more than 22. It's the next step. So if we add 2, step up 2 to 22, we go 22, 24. Okay? Now we would practice closing our eyes and just saying the product. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, right? Okay, you want to try it? Just close your eyes and say it quickly.
0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20, 22, 24.
Very good. So now we know, right? 2's. Very, very simple. And you can also, if they need more practice, you go backwards, and you pick problems out, jump around. All right? What is 8 times 2 without looking? Are you able to do it?
16.
Okay. And what is 4 times 2?
8.
Okay. And we can also see patterns here, right? All of these are even. That's one pattern. And the pattern repeats. 0, if you look at the last number, it always repeats. 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, 2, 4, and it would continue like that ad infinitum. 0, 2, 4, 6, 8. Only 1, 2, 3, 4, 5 different numerals, right? 5 different numbers. 02468, 02468, 02468, and on and on and on. Okay, so now we've studied times 2. The next strategy that we approach, mind you, we don't necessarily go in order. Normally these are taught in order, right? Zeros, ones, twos, threes. We want to be smart. We learn the easy ones first. And then, when you have to face the hard ones, a large percentage of those were already taught, right? When we learned the twos, we had 4 that we already knew. The next strategy we teach is 5 times 5. Children are often taught to count by 5s, right? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, right? And the only thing that changes in the 5s is the ending numeral is either a 0 or a what? 5. Right? The ending numeral will either be just a 0 or a 5. Okay. Let's write out a problem. All of the facts. And this takes a little bit more writing than addition. Right? This multiplication facts are very important. And you'll see some beautiful patterns. Okay, so we write 0, 1, 2, 3, 4, 5, 6. And over here, what do we write? 7, 8, 9, 10, 11, 12. We quickly establish the different numbers, okay? Then we go through times, 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 times. Times, put our multiplication sign. This will be standard. We would just be changing what's the other factor. Now we're learning 5. We're going in terms of what's easy. First easy was 0, then next was 1, then next easiest was 10, and after that 11, then after that the 2s, now 5s. Each one a little bit more difficult, but all these are basically pretty easy. Okay, so now we write 5. That's to reinforce we're doing the 5s. Okay? And then we put the little kitten whiskers. Equals, 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 equals. Things that help us learn how to do this quickly, right? Let's circle the ones that we're going to know. What's the first one we'll know?
0.
Very good. 0, we'll know that one. And we'll know what other one?
1.
Very good. And what other one?
2.
We'll know 2.
10.
10.
11.
And 11. So now we already know 5. And we only have 1, 2, 3, 4, 5, 6, 7, 8 to learn. On the last one we had 9 to learn. What does that tell us? That every time we learn a new one, it's 1 less. You see? 1 less. So now I only have to learn 1, 2, 3, 4, 5, 6, 7, 8. That's not too much. And we know that there's a pattern. 0, 5, 0, 5, 0, 5, 0, 5. Let's start filling in our answers. 0 times 5 is?
0.
The ones we know. 0. 1 times 5 is?
5.
2 times 5.
10.
We double. Okay. Let's jump over to the other one we know. What's 10 times 5?
50.
50. And what's 11 times 5?
5.
55. Very good. We repeat the number, right? 5, 5. 55. All right. Now we're ready to, we've eliminated all the easy things. Now we roll up our sleeves and we do the more difficult things. But let's take help from the pattern, right? We're counting by 5s. So that will help us. 0, 5, 10, and what's the next one? 15, right? So 3 times 5 will be 5, 10, 15. If we've been practicing counting by 5s, and we did. 15. All right? 3 is an odd number, and so when we have 5, It's also odd. Now we want to know what's 4 times 5. 4 is an even number, right? Even numbers, we'll find out. The other factor, if it's even, our answer will end in 0. If it's an odd number, our answer will end in 5. You see that pattern already, right? 1 is odd, 5. 2 is even, 0. 3 is odd, 5. 4 is even. So our answer will have to end in a 0 as a cross check. If we count by 5s, 0, 5, 10, 15, 20. Always go back and build up. That way the drill is built in. 4 is an even number, and we have a 0 at the end. Alright? So we now know 0, 5, 10, 15, 20. 3 5s are 15. 4 5s are 20. We can cross check. 4 is even, and we end in 0, 20. 5 5s. 0, 5, 10, 15, 20, 25. 5 5s are 25. Odd, odd. Odd number 5, 5 5s are 25. Okay, next one, 6. 0, 5, 10, 15, 20, 25. 30, counting by 5s. 30, 6 is even, 0 at the end of that number. 6 times 5. Okay, we know that one. That's easy. 7 5s. We go up 0, 5, 10, 15, 20, 21, 30. Next is what's the increment? 35. Very good. 35. 7 5s are 35. 7 is odd. 5 is odd. 8 times 5. Let's go back to the beginning. 0, 5, 10, 15, 20, 25, 30, 35, and 40. 8 is even, and 0 is for the even factor, other than 5. Just 2 more to go. Not so bad. 0, 5, 10, 15, 20, 25, 30, 35, 40. Next one would be 45. 9 is an odd number, right? I want to introduce this strategy in here. I think we will, yeah. 9 is a divine number. Whenever we're dealing with a 9 in multiplication, the answer or the product will have 2 numbers, right? What's the answer to this problem, 9 times 5? What's our answer?
45.
45. If I add 4 and 5, what do I get? That's your cross check. Your answer will add up to 9. If you take the 2 digits of any 9, anything times 9, your answer, you take the 2 numbers, equals what? 9. 63. 9. 18. 9. 27. 9. 36, 9, 45, 9, 54, 9, 72, 9, 81. 9 is a divine number. The product of anything times 9. We're really focusing on 5s, but we want to introduce something else that also helps us here, right? We can cross-check. The answer, those 2 numerals should add up to 9. 4 plus 5 equals 9. So we go again, we know 10 times 5, 50. 11 times 5, 55. If we count by 5s, 5 plus 5 more.
60.
Right, 60. 12 times 5 is 60. Very good. Okay. Right, then you just practice it. So now we have a strategy for 6 of them, and we only have 1, 2, 3, 4, 5, 6, 7, really. 7. And we just sort of count by 5s, and we cross-check to be sure that if it's an even number, our answer was 0 instead of ending with a 0 instead of a 5. So now we've done the 5s. Pretty amazing, huh? Amazing. Now we'll go systematically now. Now we'll go back to 3s. We'll fill in the 3s and the 4s, between the 2s and the 5s. So we just write your numerals down again. Start going fast. The idea is speed. Because we have a lot of work to do, but we want it to take it forever. We want it to take forever. We put in all our time signs.
Now it's 4:30, I'm getting a little anxious.
Okay, so we should stop. But you could see how,
I'll keep
Okay.
going, but yeah.
Okay. Okay, quickly put in all the, and now we're working with the 3s. 3, 3, 3, 3. Put the little kitten marks in, whispers. Okay, circle the ones we know. What? Right? 0s, 1s, 2s, doubles, right? 5s, 10s, 11s. Okay. And we'll take help when we get to the 9. We'll see how that applies as well. Okay? So we only have to learn 1, 2, 3, 4, 5, 6, 7. Let's fill in the answers to the ones that we know strategies for already. And we've already learned that. 0 times 3 is, 1 times 3 is, 2 times 3 is doubles, right? 6, right? 5 times 3 we learned was what? 15, right? 10 times 3 is 30. 11 times 3 is 33. Okay? Now we just have to do 3 times 3. 4 times 3, 6 times 3, 7 times 3, 8 times 3, 9 times 3, and 12 times 3. Now usually on another piece of paper or whatever, we practice counting by 3s, so then we see the automatic pattern. Okay. So we go like 0, 3, 6, 9, 12, 15, 18, 21, 24. Go up some more, we have to go 27. Should have started a little further. 27, 30, 33, and 36. And we circle the ones that we know what they represent. We circle 0, that's going to be 0 times 3. We circle 3, that's going to be 1 times 3. We circle 6, because that's going to be 2 times 3. We circle 15, we know that's 5 times 3. We circle 30, 10 times 3. In other words, now you're doing division in a way. You're analyzing factors, right? You'll give your problem and say, what are the 2 factors in 33? 11 and 3. What 2 numbers have to make 33? There won't be anything else. Sometimes you'll get other combinations that'll make factors. You may get some numbers, like 20. It could be 1 times 20. It could be 2 times 10. It could be 4 times 5. But 33 only has one set. 3 times what? 11. Okay, and then you just practice your drill. 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. You have the kids do it forwards and backwards. Just so they get used to counting by increments. And then you fill it in. 0, 3, 6, what's the next one going to be? 9. 3 3s are 9. Okay. 0, 3, 6, 9, what's next? 12, right? 4 3s are 12. 15 we know? 0, 3, 6, 9, 12, 15? 18. 6 3s are 18. Okay. 0, 3, 6, 9, 12, 15, 18. Next, 21. 7 3s are 21. 0, 3, 6, 9, 12, 15, 18, 21, 24. Okay, plus 3. Okay, here's our 9. Check that one out. 27. What does a 2 and a 7 mean?
Amazing. 9.
That's our cross check. If you have 9 as one of your factors, then the product has 2 numbers that add up to 9. And you'll see how it goes in reverse too. Because you'll start with 0, 9, 18, and the next one will be 27, then 36, then we go up to 45, and then they reverse. They go to 54, and then 63, and then 72, and then 81. At the point of 45 to 54, they just turn around. It's amazing. 9 is amazing. They reverse. Here's 27. Later on, 72 shows up. And 9 is a wonderful number. Okay? And so you just practice like that. You say 0, 3, 0, 1, 3, 3, 2, 3, 6, 2, 3, 9, 4, 3, 12, 5, 3. But now with a lot more understanding, it's not just a parrot. 6, 3, 18. You know, there's some practice and memorization involved. But each time, it's 1 less. When you get to 12, you only have to learn 1. How's that? Not bad.
Not bad at all.
Not bad at all. So after you do your 4s, same thing will happen. You'll know the 3. Then you just have to do the 4s, 5s, 6s, 7s.
And all the same pattern.
And you do like that. You count by 4s.
And you just
0,
keep
4,
cutting
8.
down.
And it keeps cutting down.
And the 9s have their special...
And they have their special
aspects.
category. So after 4s, you've done 5. You just have to learn 6 and 7s, 8s, and 12s. Not so bad, right?
And then by the time you finish the 12th, the 9 is learned automatically.
Yes. It's you're just chopping off the headache to nothing. So you practice counting by 4s. 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 40, you know, you hear it right away, 40. What are the factors in 40? 10, 4. What are the factors in 44? 4 and 11. And then you go backwards like that. You say, oh, okay, what are the factors in 16? 4 times 4. That's the way the children are automatically learning what? Division. Right? It's quick, okay? Okay, so division means you just do this backwards. After they've mastered their tables, which doesn't take long, in a few days you can master the tables.
And then you can drill them.
Right, you can drill them, right, you can do like that. And those don't even go up to 12, they just go up to 9. Right? Okay. So after you teach multiplication, the inverse of multiplication is division. Right? You go in reverse. So if we want to do, our last one we were doing was 3. Okay, cut. We'll start with an easy one. I want to divide 18 by, we cannot divide by 0, right? But we can divide it by 1. 18 divided by 1 is the same number. Anything divided by 1, strategy, same. How many times? If I have 18 and I want to give everybody 1, right? 18. 18 times. 18 groupings. I have 18 muffins and I put 1 on every plate. How many plates will I have? 18 plates. 18 and 1 are factors of the product 18. In reverse, this is the quotient and this is the divisor. If we divide 18, the quotient, by 1, we will have 18 servings. Okay? I've got 18 muffins. I want everybody to get 1. That means I can feed 18 people. Okay? It's reverse. 18 times 1 is 18. 18 divided by 1 is 18. They're just the reverse. It's like going forward, and then I put the car in reverse. Not so tough, is it? And once you start to remember these families and combinations, just as we were showing you before with addition, start to look for the family, right? 4 plus 5 is 9. So if you want to know what are 2 components of 9 in terms of addition, you would say, well, 1 plus 8 is 9. And you would say that 4 plus 5 is 9. Those are the only two components. Okay? Quotient, let's divide it by 2. Okay? Cut it in half. What times 2 makes 18?
2 times 6. Oh, sorry. We don't have to divide it.
Well, dividing by going, it's reverse, right? And I ask myself the question, 2 will go into 18 how many times? You should know 18 now
9.
because it's by counting by 2's.
9.
What number times 2 makes 18? 9. Very good. Okay, so you see it's multiplication in reverse. 9 times 2 is 18 divided by 2 is 9. Okay, and you can do the same thing in sentence form. You can go to 2 times 9 equals 18. And in reverse, 18 divided by 9 equals what? 2. And you can turn them around, right? You could say 9 times 2 equals what? 18. And you can also reverse this. You could say 18 divided by 2 equals 9. You show all the different variants of those number families. Okay, you follow that one so far?
So all you have to do is
Times 3, when we learned our 3's, the product was 18. I take that in reverse. 18 divided by 3 equals 6. That means 18 muffins. I want to give everybody, I have 3 people, everybody gets 6 muffins. Okay? Okay? 18 divided by 3, everybody gets 6 muffins. That's just practical application, so you can see. We need that because numerically sometimes we may not picture something, so you have to just practically, everybody have to serve 6 guests and they're all going to get 3 muffins. Right? And 3 guests and they're all going to get 6 muffins. So you just go backwards. That's pretty much it. You know, except for 0. Except for 0. And by this time, you should be able to recognize the quotients. You'll know them. If you see, you see a number like 36. One task you give a child is, all right, what are the possible factors? Well, first one would be 1 times 36, right? Another one would be 2 times 18. And another possible factor would be 3 times 12. And another possible combination would be 6 times 6. After a while, because later in higher math they start doing that, you really become, it's very good, it's very analytical, the mind really becomes very sharp. You see a number and then right away, you know what all of its possibilities are. I have 36 muffins. I can give one person all 3 dozen, like you.
Why not?
I can give 2 people 18, like when your mom came. Right? Your mother-in-law came. I ordered 12 muffins. That means each of you gets 6. No, I think I gave away 2. I gave 2 actually to Prabhu. Did he give 1 to you? I don't know if he did. Anyway, I'm ordering some muffins for you before you go. You deserve it. If I want to give 3 people muffins, then I have to reduce the amount each gets to 12. Right? If I have 6 people to feed, then I have to reduce the amount of muffins to 6. I'm fixed. I have a fixed number of muffins, 3 dozen, right? And again, if I have going up a little bit, 12 people, right? 12 people show up, then everybody gets 3. And then if 18 people show up, everybody gets 2. And if 36 people show up, everybody gets 1. Okay? So depending how many people show up, I have to divide them proportionately. Okay? one guy shows up, he gets 36. But if 36 people show up, everybody gets 1. If 6 people show up, everybody gets 6. So that's just a simple way to understand division. It's grouping. It's just grouping in reverse. Because multiplication is grouping too. If I say 4 times 3, that means I have, talk about plates. 3 here, 3 here, 3 here. That's a bad number because it's not so good. Auspicious for serving something. 3, if I have 4 times 3, I mean I have 1, 2, 3, 4 little plates, and each of them has 3 muffins. Right? That's practically what this means. It's grouping. How many times do I have a group of 3? 4 times. If I have 5 times 3, then I have 15 total, right? So that's how that works. So it's a matter of just going through it not only systematically with the strategies, but if people, like in your case, didn't have so much practice with tables, it's important to graphically show it so you have the concept behind it, so it just doesn't become a series of numerals. That's not desirable. That just makes you, like in the same Indian program, where it's just a memorization with no grasp. It's not deep. But if you see things, just picture it.
They lose your memory.
Yeah, they do. Depend on your memory, which can fail you. And even if it is not going to fail you, if your understanding is superficial, just like in spelling, somebody may be a very good speller because his memory's sharp. But the little kid who knows Spalding in the first lesson can tell you more than he can. Right? The little first grader is more, his knowledge is a greater level than the guy who's got a photographic memory. He may not know what there are 5 silent E's, right? So you sort of got it? And then, that's it. Do the 3s, you have to learn the 4s, 6s, 7s, 8s. The 9s are they're fun. They're fun. And then 10s 12s and with the last one you just add 1 more. And by the time you get to 12 12s, you have learned 11 12s. So 11 times 12, that was our trick, 132, right? And 12 12s, 12 times 12, you just add 12 more. And that is 2 4, I'm trying to think, is 42, no that's not right. 12 12s, 144, okay, 144, yeah, 144. That's the only one you have to learn. Because you'll know 10 12s, 120. 9 12s, it's 108, that's a good one. 108, that's easy to remember. Gopies. 8 times 12, 70. That's 170, 672, 8 12s, 96. Okay? So there's a little bit of work there, but you just do it like this systematically, drill with increments. Each time it gets, 1 job less. And the bigger it gets, maybe the problem looks like the numbers are bigger, but you have 1 less to learn each time, right? So there's that motivation to move better, okay? Now, I did want to take a moment just to show you a couple books in your bag.
Is it possible do you have any other tricks with the division?
Just basically that,
Any
well,
strategies?
yeah, if you're dividing by 1, it's going to be 1, the same number, right? 5 divided by 1, and you can always have your little back sheet here, right? It's right on the other side, isn't it?
Yeah, it says it there.
You can double check them. Double check if you're not sure.
But any
So-
special tricks or strategies?
Strategies,
for
yeah,
it?
just sort of the obvious ones like multiplication. Anything divided by 2 is going to be half.
Right.
And then we don't have 10s here. The 5s, well, it's pretty much knowing recognizing the product, because you'll know the factors. If you learn by your multiplication, you look at 40, and you've already learned that 2 factors of 40 are 5 times 8. You know, by having done the multiplication. One combination is 5 times 8. Another would be 1 times 40. Another would be 2 times 20, right? Another one would be 4 times 10. And another one would be 10 times 5 times 8. So one good thing, good practice for the brain is to take these numbers.
So it's basically just times tables.
Yeah, once you know your tables. See, that you go in reverse. It's just like your subtraction. Once
So
you do your
whatever's
addition,
strategies for your
you
times
just
tables
go backwards.
is right.
It's backwards, that's all.
It's just figuring out times tables.
Yeah, you just have to practice your times tables. But you saw now, you covered quite a few, right? In a very short time. All you have to do now is learn the 4s, the 6s, 7s, 8s. And then the 12s will be just one more. Not too bad. And you just start with counting by that number at the bottom. Like 6, then 12, then 18, right? Then 24, then 30, and then 36, and then 42, and then 48, and then 48 plus 6, what, 54, 6 nines, then 60, then 66, and then 72. The exercise is to take any number and factor it, give all the possibilities. Okay, so let's take number 32. Let's give all the possible ways to factor this number. So you start with 1. Will 1 go into 32 evenly? 1 will go into any number. So that's right off the bat. 1 times 32. There are 2 factors that make 32, okay? Let's try, will 2 be a factor? Will 2 go into 32 evenly? Yes. The other factor will be, what? 16. Will 3? No, not evenly. It won't go evenly.
So you can
4?
just keep going through and
Yeah, just like that.
you can figure out divisions with 32 or anything, subtraction,
Right.
figure out everything. Amazing, thank you so much.
And then 8 will go in, 8 will go in. 4s are 32, 4 8s. You get all the factors and all the possible positions. It could be 32 times 1, 1 times 32, 2 times 16, 16
You
times
can
2.
also figure out what won't go into 32.
Exactly. So that way you start to recognize, and it becomes after a while just common, like, you know, somebody's name, you can spot a person's name. So you look at 45 and right away you know, well, 9 times 5. 9 times 5 is 45. You'll know right away what the factors are. You don't even have to see the problem. You'll know right away. Also, 3 will go in. It'll be 15. You know, there's some that are a little more difficult, but the basic ones, 9 times 5 is 45. And you'll see another number. Well, there's 36. Well, 6, 36, right? 6 another times itself. That's another thing to learn in multiplication really easily. Number times itself. You learn 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. That's another way to chop them off. You know, learn all those, a number by itself. And you learn those 4 times 4, 5 times 5, 6 times 6. Because that's helpful in learning square roots. Because then if you want to know, because that sign is this sign, 36, what's the square root of 36? It's 6. That means the number times itself. Where do they put that, on top? If you have a square root sign, or do you put it outside? On top?
Copies answer.
Above, right?
Answer.
Here,
Yes.
6, right? 6 times 6 times 6. The square root of 36, that means what number times itself makes 36. So you'll know the number, you'll recognize right away, numbers that have a square root, right? So 9 has a square root. What times what makes 9? Do you know offhand? You know, what times what makes 9? 3. 3 is the square root of 9, right? This means the number times itself. So you'll learn right away to see those products that have a square root. That means that number times itself. So the square root numbers are 4, 2 times 2, 9, 3 times 3. By counting, you can do it. See? You count. 2 times 4, 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. So then in reverse, 16 has to have a square root of 4. Okay? Sort of follow that one a little bit? Now that numbers times 5 times 5. Yeah, 5 times 5 is 25. Square root of 25 is 5. 6 times 6 is 36. Square root of 36 is 6. 7 times 7 is 49. Square root of 49 is 7. 8 times 8.
Everything is times 5.
Everything. 8 times 8, 64. Square root of 64 is 8. Okay? No problem. So I just thought that would be really helpful. I did want to just do a little bit of the rainbow thing.